Final lesson of our confidence interval unit 7.6. How many states can you name? How many states can you name in a minute? So I had all of my stats students write down as many states they could write down on a piece of paper. And then I have all of the class data, and I've taken it and put it into Staplet for one quantitative variable. I want to find the mean, standard deviation, the sample size, and then have the dot plot as well. So here's all of my data. There's my dot plot. So I'm just going to copy and paste that over. And then I'm also going to copy paste the summary statistics over as well. So there's my, let's copy the graph and paste it. Look how beautiful that is. And then I'm going to, I don't need the 5-number summary, so I'm just going to copy, let me try that again. I'm going to copy just the sample size, the mean, and the standard deviation over as well. So I have those values. And now I want to construct a 95% confidence interval to estimate the mean number of states any senior can name. So first we're going to state what we're doing. We're going to state our parameter. Our parameter is going to be mu. So I have to go to my equation editor here and get mu. And this mu is going to represent, it is the true mean number of states a senior can name. And our confidence level that we're told right in number 3 above is 95%. Our method, so we only had one procedure from a couple classes ago. Now we know how to find the confidence interval for means. So we want a one sample t interval now. So we specify t because we need to use t for means. And I again want this mu as my parameter as well. No, I want it as my parameter. There we go. I don't want the word mu. I want the actual symbol, mu. We're going to check conditions, random, kinda, check. Yeah, you guys were randomly chosen, a lot of all my stats students. And then we check normal. Oops, wrong keyboard. Normal. I had more than 30, so we can say normal by the CLT. My sample size is 40, was it 41? It was 40, which is greater than or equal to 30. So it's normal by the CLT. If we don't know the population, you can also look at the dot plot. I might see a couple outliers out there. I can check using my outlier formula, but it does look pretty normal just from the distribution there. So that's another way we can check normal, is we can check that's by the CLT or the population distribution appears normal. However, that's not every senior, that's just my stats seniors. Our general formula, we're going to take the point estimate, our sample mean, we're going to add and subtract the margin of error. And so we got our formula for that. I think we have that up here. So we're just going to copy that formula real quick from page 10, or I think we have it on page 9 as well. So our formula we're going to use right there. Can change that so it is x bar. So we're going to add that bar over the x because that is our sample mean. And then we can plug those values in. For our sample mean, it looked like we were 18.275. I don't know where I'm typing. There we go. And we want to add and subtract a critical t value, which, goodness me, it's going to be the same one we're using over and over again. In order to find critical t values, here we are at the stats AP formula sheet and tables for 2020. I think they might have updated this and posted their 2021. First, we're looking for DF. DF means degrees of freedom. Degrees of freedom is n minus 1. So our sample size, again, was 40. So we're looking for degrees of freedom of 39. We do not see 39 on here, so we go to the next lowest value, and so that's going to be 30. So our degrees of freedom we're using here is 30, and our confidence level is 95%. So I'll look at the bottom here, 95% corresponds to 2.042. So I can go over here, 2.042, and then we want to multiply that by the sample standard deviation, which was 7.002. So we can type out 7.002 divided by the square root of, where's my square root key? There's square root of the 40 in my class. So I'll multiply all that together, 2.042 times 7.002 divided by square root of 40. Hopefully I can type it in correctly, 2.042. And then so that will give us 18.275 still, plus or minus 2.261. And so I'll add and subtract that. So 18.275 minus 2.261, and then plus 2.261. So we get a confidence interval of 16.014 to 20.536. And then finally, we're going to interpret what our interval means in the context of the problem. So we can say that we are 95% confident that the interval from 16.014 to 20.536 captures the true mean number of states a senior can list in 1 minute or 60 seconds. So basically what we did last class, now we just have a little bit of a format to it where we state, plan, do, and then conclude. And then another round of little notes on checking the normal condition. We can either see that the population is normal. We can see that n is greater than or equal to 30, and that's by the central limit theorem. Or the graph of the sample data has no strong skew or outliers. Goodness, if only that was a little bit smaller. That would be perfect. There we go. So nice and easy there. You're going to practice this on application 7.6, and then we're going to wrap up our notes here and put everything together in a nice, neat formula study sheet here for you. And then there's some practice problems, some big ideas, all at the bottom of this CAMI as well, and some blank 4-step process as well that we can practice in class to make sure you guys are confident with confidence intervals. You see what I did there? I see what I did there. All right.